In the previous video, we have defined the fundamental node class that we can use for representing each and every node that we have inside a single linked list class, right? In this video, let's try to define the similar class that we will use for representing the single linked list as well as for adding all the functionalities that we need to have inside any linked list class. So when I explained you the terminologies that we have inside the single linked list class, right? So I clearly mentioned the very first node we have inside the single linked list class, we will call it as a head node, and the very last node we will call it as a tail node of a linked list, right? So in the linked list that we are going to implement, specifically the single linked list that we are going to implement, it is very important that we have the access to the head node. Once we have the access to the head node, right, this is of type node that we have defined earlier, right? So in this node class we will have the value and we will also have the reference to the next node. So using that next node, from the node 10 we will be able to go to the node code. Similarly, from the node code we will be able to go to the node true. Similarly, likewise, we will be able to reach the very last node, that is false. Once we reach the last node false, at the last node the next pointer that we are maintaining is basically empty, using which we will be able to say we have reached the end of the singly linked list. So here our aim in the process of representing the singly linked list, right, we have to have the access to the head node for sure. So our primary criteria that we should have inside the class that we are going to define will be head pointer should always be there, okay, and it should always point to the first node we have inside the singly linked list. And the second thing is, as part of implementing some of the functionalities such as push functionality, where we try to add the new value at the end of the singly linked list, at that point of time, if we have the access to the tail node, right, we will be able to add that new node very easily. If we don't have access to the tail node, right, first our implementation would be requiring you to go to the very last node. After going to that last node, we will be able to add the new node there. That's why, to reduce that functionality, and what exactly we will do is we will maintain one more value called tail inside the single linked list representation. So just you have to remember that the tail node reference that we are maintaining inside the single linked list, we are trying to use it in such a way that it will reduce the complexities involved in some of the operations that we implement later on. That is something that you have to keep it in your mind. And inside the tail variable that we are going to define, we will always keep the reference of the last node in that variable. Besides these two variables, right, obviously head is the first node and tail is the last node. So besides this, some of the common functionalities that we implement are insert, remove, and get and set are some of the functionalities that we will have inside the single linked list, right? While implementing these functionalities, what exactly we will do is we will try to take the index from the user. So the index, based on the value that user is passing, we will try to perform that specific operation. At this point of time, you don't have to worry, but you just have to remember that just like the operations that we have in the array, where we take the index and we try to update or insert a new value at those indexes, we will try to perform the similar operations in the case of single linked list as well. So to make sure that user, whatever the value that we are taking from the user, if it is falling in the valid range or not, we will also try to maintain the length of the singly linked list as well. So just like how tail that we are maintaining, that is making the process of implementing some functionality easier, the process of keeping track of length also will definitely help us in implementing some of the functionalities very simply. If we don't have the access to the length, right, first our job would be to our job would require us to start at the head node and traverse till the tail node, and then find the length of the linked list and use that length for implementing the functionalities. This will basically increase the time complexity. So to make sure that we are bringing the time complexity down, we will also make sure we are maintaining the length of the singly linked list as well inside our implementation. So these three variables we are maintaining inside the class that we are going to define for representing the singly linked list class. So for class representation, what exactly we will do is we will define a class called singly linked list. Okay, inside this linked list, what we will do, we will define three variables. One will be head. Remember that this head should always point the first node of the singly linked list, and each and every node is of type node that we have already defined previously, right? So we have to make sure that the node type objects are getting assigned to this. Okay, similarly after head we will also maintain the tail node. Similarly in the tail node we will always make sure whatever the operation that we are trying to perform, we will make sure that always the last node reference is available inside the tail. Similarly, this just like how we are maintaining in the head node, the object of the tail node will also be exactly of type node that we have defined. And along with this we will define one variable which will basically contain integer values, since length is an integer, right? In this length we will maintain the length of the singly linked list. Once we successfully define that class, inside the Python implementation, what exactly we will do is basically at the time of object creation, obviously there are no values inside the singly linked list. That means whatever the head, tail and length we are maintaining, we have to initialize it with the appropriate values, right? For that, what exactly we will do is we will add the init method, and inside this init method, right, whatever the head node that we have, we will initialize it with none value. Similarly, the tail node also we will initialize it with none value, because there are no values inside the single linked list. That's why head is pointing at none, and we will make sure that tail is also pointing at none. If at all, if we have the proper nodes, we will make sure that references or the objects of those nodes are available in the head and tail node as well. Similarly, besides these two values, we are keeping track of the length also, right? And length, obviously at the time of object creation of that singly linked list class that we have defined, at that time there are no nodes. That means that length of the singly linked list is 0. So we will initialize length with 0. Okay, so that is the theoretical implementation of defining the class and creating the object of a singly linked list. In the next videos we will get on to implementing all the functionalities that we have decided that every linked list should contain, right? Such as push, pop, shift, unshift, and various operations that I have mentioned when we discussed linked list as an abstract data type, right? So we will go ahead and we will implement all those functionalities one by one, and we will make sure that we are storing the appropriate values inside the head, tail and length according to the cases that we are seeing while we are implementing that specific functionality. Okay, now we have discussed enough theory about this representing of singly linked list class. Let's go ahead and let's write the Python specific implementation as well. So inside the singly linked list folder that we have created previously, I'm going to create a new file called singly linked list. I'm going to create a new file called singly linked list.py. Okay, in this class, if you remember the discussion that we had earlier clearly, in singly linked list we have three values. One is head node, which is nothing but the starting or the first node inside the singly linked list, and the tail node, which is nothing but the last node we have in the singly linked list. Along with that, we are also trying to capture the length, which will basically give the total number of nodes present inside that specific linked list. So to represent these three values, what I will do is I'll define a class. Let's call the class as singly linked list. Okay, in this class, when I create the object, I basically have the empty singly list. That means head will be pointing to null, tail also will be pointing to null, and the length will also be 0. So to initialize such empty object, what I will do is I will use this init method to initialize it with the default values, that is self. And as part of this initialization, what I will do is self dot I will create a variable called head, which will be the reference for the starting point or head node of the singly linked list. In the beginning, it will not have any valid value, right? So I'm simply assigning it with none. Similarly, when we initialize a empty singly linked list, there will also no tail node. Simply for that, I'm going to create a variable called tail, and I will also assign none to it. Okay. Similarly, when we define empty single linked list, there will not be any values, right? So obviously length will also be 0. To store the length of the single linked list, I'm defining a variable called length. I'm assigning it to 0. Okay, so this is how we represent the singly linked list object. Okay, in the later operations, we will go ahead and we will try to perform each and every operations based on the definition and the implementation of it, so that we have a fully functional singly linked list. Okay, but don't forget that this node will be of type node that we had defined earlier, and similarly the tail will also be of type node that we have defined earlier. Okay, using these nodes we will be able to store the next and next till we reach the end of the linked list, which is at the tail node. To validate the Python logic that we have written here, let me just create the object and let's just try to print the head and tail and length values, so that we will be sure that we are creating the object of a empty singly linked list. For that, what I will do is I'll simply create a object SLL equal to singly linked list. From here, when I create the object, it is going to call the init function. In init function, we are simply assigning none to head and tail and 0 to length, because it is empty when we are initiating the object of singly linked list. Now if I simply print SLL dot head, print SLL dot tail, simply print SLL dot length. Okay, since we are creating an empty singly linked list, there will not be any values in it at the beginning, so simply all the head and tail will be pointing to none and length will be 0 here. Okay, let's simply execute it. If you remember, we have written this singly linked list file inside the folder singly linked list, right? So the command will be python 3 singly linked list, and the file is singly linked list.py. Okay, so if you see the log, we are able to see none, none and 0. Okay, that means we have a empty singly linked list created successfully. In the later videos, we will be going ahead and we will be creating, we will be performing different sort of operations, so that we will have a valid singly linked list containing certain number of values, so that we will have a valid reference for the very starting point in the head variable and valid endpoint in the singly linked list in the tail variable, and we will also have the valid size or the number of nodes present in the singly linked list in the length variable. Okay, I'll see you in those implementations.